Okay, so today we are going to move on to cluster 5B, day 9, which is basically finding the distance between 2 points. So we're going to start off with number 1. The directions state, find the distance between each pair of points. Round your answer to the nearest tenth if necessary. So we're basically finding how long this line is. Okay. So, in other words, what is the distance of that line? So, before I can do anything, what I'm going to do is I'm going to use the graph to create a right triangle. Okay. So, as you can see, I have created the right triangle. There's actually another way that you can create a right triangle is by going down and over. It really doesn't matter which right triangle you create. Okay, you can go up and over, or you can draw it going down and over. It really doesn't make a difference. Now, what I'm going to do is I'm going to count the units on this vertical line or line segment, and then I'm going to count how many units there are on the red line. Okay, so 1, 2, 3, 4, 5, 6, 7. So this line or this side of the right triangle is 7 units. Now on the side of the triangle that is in red, that's 1, 2, 3, 4, 5, 6. So that is 6 units. Now using these two measurements along with the Pythagorean theorem, which is a squared plus b squared equals c squared, I should be able to figure out the missing measurement, which is the highlighted side of the triangle. Now, of course, my next thing to do is to identify which of these sides is the letter C. Across from the 90-degree angle is your letter C. The other two sides are A and B. So with that being said, I can plug in these numbers into my theorem. So 6 squared plus 7 squared equals C squared. Now, I'm going to go ahead and give my computer, Desmos, or tablet, phone, or whatever, and head over to Desmos. Now, the first thing I need to do is I need to figure out what 6 squared plus 7 squared is. So if you go to Desmos, you're going to click 6, and the square is this button that looks like a to the power of 2. If you click that, that gives you the square, in case you forgot. So 6 squared plus 7 squared, and that gives me 85. Now the opposite of a square is the square root. So once again, let's head back to Desmos. So the square root of 85 is 9.21. Okay. And it's okay if you want it around to 9.22, as long as you have a 9.2 something. Okay. Now let's move on to number 6. Once again, they're asking me to find the distance between those 2 points. So to be able to find the distance, I need to create myself a right triangle. So this time I'm going to go up and then over, and that gives me my right triangle. So now let's see how many units the red side of the triangle is. 1, 2, 3, 4, 5. Now let's see how many units is up here. 1, 2, 3, 4, 5. Okay. And then of course the other side, the diagonal, is missing. So using my theorem, a squared plus b squared equals c squared, I need to identify what A, B, and C are. So the first thing I need to do is identify what the letter C is. Across from the 90-degree angle is your letter C, which is the hypotenuse. The other two sides are A and B. So A can be 5 square, B can be 5 square, equals C square. Now 5 square plus 5 square, okay, and if you go back to Desmos, 5 square plus 5 square, that gives you 50. So we have 50 equals C square. Then the opposite of a square is square root. So the square root of 50 gives me 7.07. And that is the distance of that green line. Okay, that's how long it is. It is about 7.07 units. Now, it's important that when you're finding the distance of this line, you cannot count down the line. So don't sit here and say, well, Mr. Gomez, if they're asking me to find the distance, couldn't I just go 1, 2, 3, 4, 5, 6? No, that's not how it works. Okay? You have never been told that you can count on a graph paper on a grid diagonally. You can only go up and down, left and right. So that is why we can't just simply go in here and say, oh, let's just count the line, the diagonal line. 1, 2, 3, 4, 5, 6. Okay? And as you can tell, my answer was 7.07, not 6. So that is why we have to use the Pythagorean theorem and create a right triangle so we can be able to find the distance, okay? It's not as easy as just counting along the line. Okay, let's go ahead and flip to the next page. So number 13 says, what is the distance between the points -6, -7, and 6, -2? So what I'm going to do is grab a piece of graph paper. You should have received a couple copies when you came to pick up your green book. So let's go ahead and just choose one grid to go ahead and solve this problem. So the first thing I'm going to do is I'm going to put down my 2 points that they gave me. So -6, -7, it's right here. And then 6, -2. And then do your best to connect it. Okay, and that's going to be my distance. That's what I'm looking for. So I'm going to put a little question mark there. Now the next thing I need to do is to be able to find the distance, I need to draw myself a right triangle. So this time I'm just going to drop and go over. And there's my right triangle. Okay, so now let's figure out the measurements or the units of each side, okay? So here I have 1, 2, 3, 4, 5. So this side of the triangle is 5 units. Now let's count the units on the side that is shaded red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 5 units here, 12 units there. And of course, we cannot count on the diagonal line. So there's no need to try and count that side. So now let's identify what my letter A is, what my letter B is, and what my letter C is. So I can go ahead and use my theorem. So across from the 90-degree angle is your letter C. The other two sides can be A and B. So A squared plus B squared equals C squared. When I plug those numbers in, I get 5 squared plus 12 squared equals C squared. Now using Desmos, I'm going to figure out what 5 squared plus 12 squared is, and that gives me 169. equals c squared. Now the opposite of a square is square root. So the square root of 169, you should already know this because this is one of the square roots that we talked about back in Unit 5A. So the square root of 169 should be 13. So that means the distance of that diagonal, or the distance of that line, is 13 units or whatever they're using, okay? So if we go back to number 13, the answer will be D. Okay? Let's move on to number 15. 15, they went ahead and gave us the picture. So they're asking me, triangle ABC is a right triangle. What is the length of side AC? Okay, so the side of AC is right here. So that is what I'm looking for, okay? That's my missing side. The other two sides I can just go ahead and count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And of course, I'm going to use my theorem. A squared plus B squared equals C squared. Across from the 90-degree angle is your letter C. So C is what we're looking for, which is the diagonal. So the other two sides can be A and B. So here we go. 3 squared plus 7 squared equals C squared. Using decimals, I'm going to go in there and plug in 3 square plus 7 square, which gives me 58. And the opposite of a square is a square root. So the square root of 58 is 7.61. Okay. Now let's look at our answer choices. Okay. If you notice, our answer choices are in square root form or radical form. Okay. So I have two options. I can either go in there into each answer choice and convert the square root of 20 into a decimal, square root of 21 into a decimal, and keep going down the line and see which of these answers converts to 7.61. Or you can just go back one step and you will notice that the square root of 58 is an answer choice. So clearly, square root of 58 is the same thing as 7.61, which is what we typed in, okay? Now let's move on to the last problem, number 16. It says the vertices of a triangle are located at R, S, and T. What is the approximate length of line segment ST? Now for this one, I'm going to go ahead and use my graph paper. And let's go ahead and plot RST. Okay, so R is 3, 4. 3, 4. Okay, and then 3, -1, and then 6, 4. So R, S, T. Connect your dots as best as you can, and go ahead and identify which of these sides is ST. And ST is right here, so that is what I'm looking for. Now let's count our units. RT is 1, 2, 3. Okay. RS is 1, 2, 3, 4, 5. And of course, across from the 90-degree angle is your letter C. And the other two sides can be A and B. So using my theorem, a squared plus b squared equals c squared, I can find the missing side, which is the hypotenuse or the diagonal, okay? Whichever name you want to use. So 3 squared plus 5 squared equals c squared. Now using Desmos, I'm going to figure out what 3 squared plus 5 squared is. 3 squared plus 5 squared gives me 34. So 34 equals c squared. Now the opposite of a square is the square root. So let's identify the square root, okay, of 34, which is 5.83. So the missing side, or the distance of ST, is 5.83. Now let's go back to the answer choices and see which one matches ours. So we said that the letter C equals 5.83, and that will be ST. Okay, so the approximate length of line segment ST will be roughly 5.8, which is answer choice A. Okay. If you have any other further questions, please do not hesitate to contact me. I'll see you soon.